Okay, so we continue with straight line graphs, and we're going to look at how to find the equation of a straight line. So hit pause, make some notes. When you're ready, hit play again. So earlier on we looked at how we found the gradient of a straight line. And if we look at that again, if we have 2 points on the straight line, got a point here and this one here. So if we say this one is xy and this one is x1, y1, then to find our gradient, if you recall, we call it the rise of the run, or the change in y divided by the change in x. So the change in y, this is going to be y minus y1 from here to here, here to here. And the change in x is going to be from here to x1, so it'll be x minus x1. So our gradient m is equal to y minus y1 divided by x minus x1. If we simplify by, instead of dividing with the x minus x1, we multiply by the x minus x1. So we got m times x minus x1 here equals y minus y1, and this is the equation of a straight line. It's normally written though by switching. So we have y minus y1 equals m, the gradient, times x minus x1, and that's your equation of a straight line. So what I want you to do now is hit pause, make some notes, and when you're ready we'll use this in an example. Right, let's have a look at this example here. Find the equation of the line with gradient 5 that passes through the point 3, 2. So we want to find the equation of a straight line, or in the form of y equals mx plus c. Now we use this formula here, y minus y1 equals m times x minus x1. Like we say, always write the formula down. It just helps the memory. We get used to it. Now we've got the coordinates of one of the points there, 3 and 2. So we can sub that, and we've got the gradient. We can sub that into our equation. So we've got y minus the y value, which is 2, is equal to the gradient 5 times x minus 3. So we expand and simplify. Y minus 2 is equal to 5x minus 15. And so if we're going to make it a general form, we can say y, 5x is positive on that side, so it becomes minus 5x minus 2 plus 15 is equal to 0. And my equal signs have just gone slightly awry. And so as we simplify that as y minus 5x plus 13 is equal to 0. That's job done. So that's the equation of a straight line. I know you're used to writing it as y is equal to 5x minus 13. Either form is fine. Okay, so that's our equation using our formula. So hit pause, make some notes. When you're ready, hit play again. Okay, let's have a look at this example. Find the equation of the line which passes through 5, 7 and 3, minus 1. So I've got 2 coordinates, but I don't have a gradient. How can I find the gradient then? And then if I can find the gradient, I can use my formula to generate the equation of a straight line. Well, if I use this formula here, I can find the gradient. So taking these 2 points, I tell you, just to be different this time, we'll call this point 2 and this one point 1. So m is given by y2 minus y1 over x2 minus x1. So we're going to find the gradient first, which is equal to, we said this is 0.2, so it's going to be 7 minus 1 divided by, then the x value, 5 minus 3, which is equal to 7 plus 1, which is 8, divided by 2, so our gradient is 4. Now I can find the equation of a straight line because I know I'm going to write it down this side here. So I know that my equation is given by y minus y1 equals m times x minus x1. Now it doesn't matter which coordinates I use. Either is relevant. Either one will generate the same equation of a straight line because both points lie on the straight line. So if we use 1, say, so you get y minus 1 is equal to the gradient of 4 times x minus 3. Expand and simplify, so you get y plus 1 is equal to 4x minus 12, and in the form which we're used to, that gives us y is equal to 4x minus 12 minus 1 equals 4x minus 13. Again, hit pause, write the example down. When you're ready to move on, hit play again. Okay, this example here, we've got the line y equals 3x minus 9 crosses the x-axis at coordinate A. Find the equation of the line with the gradient, so they give us a gradient, 2/3, that passes through A. So the line is going to pass through the point A. Give your answer in the form of ax plus by plus c equals 0, the general form. A, b, and c are integers. So in order to do that, I don't have coordinates of any point on the line, but I can generate them because I know that this line crosses the x-axis at point A. So I can find those coordinates at point A. I need that first to start. Where it crosses the x-axis, we know the y value is going to be 0. So y is equal to 3x minus 9. And where it crosses the x-axis, so if we write that as the equation crosses the x-axis, y is equal to 0. So that means that 0 is equal to 3x minus 9, and so 9 is equal to 3x, and 9 over 3 divided by 3 is equal to x, which implies that x equals 3. So I've got coordinates then at A, and they're given by 3, 0. So I've got coordinates now passing through the line. Great. I've got the equation, the gradient of the equation. M is equal to 2/3. So now I can find the equation of the straight line. Now I use my y minus y1 equals m times x minus x1. It passes through point A. They tell us that in the equation. Find the equation of the line with gradient 2/3 that passes through the point A. So I've got y minus 0 is equal to 2/3 of x minus 3. Expand and simplify. I'm dividing by 3 here, so if I multiply through by 3, I get 3y is equal to 2x minus 3. So 3y is equal to 2x minus 6. And in the general form that they want over there, that means 3y minus 2x plus 6 is equal to 0. Job done. Okay. So that point A has got two lines going through it. The line in the first instance, and then the equation of the line which we've just generated. So what I want you to do now is hit pause and make some notes. When you're ready to move on, hit play again. Okay, let's take a look at this example here. The lines y equals 4x minus 7 and the line 2x plus 3y minus 21 equals 0 intersect at point A. Point B has coordinates of minus 2, 8, find the equation of the line that passes through A and B. Okay, so they've given us two lines and they say they intersect. If two lines intersect, I can find the coordinates where they intersect by solving them. Because now I've been given two equations with two unknowns. We got y is equal to 4x minus 7. That's the first equation. I've also been given 2x plus 3y minus 21 equals 0. That's equation number 2. Two equations with two unknowns. I've got simultaneous equations. So how would I solve this? What's the best way of going around solving this? I could rearrange this to make this y equals and then eliminate. Easier in this case to substitute. So if I sub, let's just draw a line here. So substitute for y in equation 2. Now equation 2 is 2x plus 3y minus 21 equals 0. So if I sub y is equal to 4x minus 7, so that means I've got 2x plus 3 times 4x minus 7 minus 21 equals 0. Expand and simplify. I've got rid of y, I've only got terms in x now. So that gives me 2x plus 12x minus 21. Interesting. Minus 21 equals 0. So that gives me 14x minus 42 is equal to 0. 14x is equal to 42. That's minus x on this side, becomes positive on that side. So x is equal to 42 divided by 14, which means that x is equal to, how many times is 14 going to 42? Could that be 3? So those are that's my x value. How do I find the y value now? To find the y, I sub for x in that equation. So sub for x in equation 1. Now y is equal to 4x minus 7. But we know x is equal to 3, so y is going to be equal to 4 times 3 minus 7, 12 minus 7, which gives us 5. Y equals 5. So coordinates of A are given by 3, 5. So we've got two coordinates, and now we want to find a line that passes through A and B. So let me just draw a line here. Right then, so we've got coordinates of A, which we've just found, 3 and 5, and B, minus 2, 8. Now I need to find the gradient first, and then I can use my equation of a straight line. Now the gradient M is given by, M is equal to y, change in y, y2 minus y1 divided by x2 minus x1. If we say this is 1 and this is 2, doesn't matter which way around we go. And so we got m is equal to y2, so 8 minus 5 divided by minus 2 minus 3, which is equal to 3 divided by minus 5. So our gradient is minus 3 over 5. So now we can use our equation of the straight line. Y minus y1 equals m times x minus x1. And it doesn't matter if we use A or B. Now because A has got two positive terms, I'm just going to stick with that. Doesn't matter which one of them you choose, and you can try this out yourself just to make sure. So I've got y minus 5 is equal to minus 3 over 5 times x minus 3. So simplify, I'm going to multiply through by 5, so that gives me 5y minus 5 is equal to minus 3x minus 3. Simplifying, I'm just going to put a little line here for me to finish. So expanding out, 5y minus 25 is equal to minus 3x plus 9. Doesn't want it in any specific form, but because I've got a minus x, I'm going to bring everything over to the one side. So that leaves me with 5y plus 3x minus 25 and then minus 9 equals 0, and simplifying that gives me 5y plus 3x minus 34 is equal to 0, and that's the equation of the line that passes through A and B. So I want you to follow through that. It's gone a roundabout way. We started here. Tell you what, I'll change pen so we can see the direction of travel. So we started here, finding the, we've got two equations and two unknowns simultaneous, finding x equals 3, plug that back in, and then we found a y value, which is 5. Then we found our coordinates for A, and then we got A and B, and this is part 4 then. So we found A and B, and then we used our equation to find the gradient, and once we found the gradient as minus 3 over 5, we found y equals mx plus c in general form. Good. So make some notes, and when you're ready, we shall move forward. So hit pause when you're ready, hit play again. And it's your turn to do some work. So exercise 5C. I'd suggest maybe going down the left hand side of the page again. Do questions 3, 4, 5 and 6 as well. Okay, and if you're feeling up to the challenge, attempt the challenge question. So page 94, exercise 5C. Good. Good luck.